Nisam siguran, ako me prije, nisam siguran. Pitala je me nova.
Vrata se ovo.
Hoćeš? Ovo ćemo crno konobara.
Hello. Hi. First of all, hi. Thanks for coming. Usually we host this introduction part a bit longer, but we are going to switch that for a bit later on. So yeah, I'm just going to introduce our speaker, who is Townsend. He works for Shift Commerce. He's there. He will host a talk called Building Fast Website Against All Odds that won the award as the best talk at the Dev Days in Berlin. So yeah, I'm sure you are in for a treat. It's going to be a great talk. So Ryan, take it away. Don't really know what to put this down. Okay, so welcome everyone. I'm here to speak about building faster websites. The talk's entitled Building Faster Websites Against All Odds. So I've been dealing with performance for many, many years, and often selling it into clients and things like that is quite tricky. So it's sometimes a bit of a battle. So before we kind of get into things, obviously I need to introduce myself to you because not many people will have heard of me. So I come from the north of England, a city called Leeds, if you might have heard of the football team. I know it's the topic of the moment. I'm probably having to fight against some of the football teams playing at the moment. But yeah, so I work for a company called Shift, not related in any way to the Shift conference that happens here in Split. But yeah, Shift Commerce, so it's kind of a similar name. And I'm the CTO, so I've progressed through doing web development for the past 15 years. I've done everything from front end, back end, server stuff. I've managed a team, and then now I kind of sit above all of that and manage more of the product side of things as well. We get to fly around the world and speak to awesome developers, so I'm pretty excited to be here. These slides, by the way, are all on speakerdeck.com/Ryan Townsend, which is my name. So if anyone can't see this or has trouble following it, feel free to bring it up on your phone. Yeah, so at Shift, what we do is we build an e-commerce platform. It's aimed at kind of mid to enterprise scale retailers, so quite large companies. This is one of our largest clients, a company called Matalan in the UK. They're a clothing retailer and they do over £1 billion in revenue each year. And they have about 220 physical stores, so they're obviously quite a large company. And when it comes to performance, it's something that's very kind of close to our hearts in terms of our company and to our clients. So I don't know how many of you have been to the previous Tinel meetups. There was a friend of mine called Harry Roberts who spoke, I think it was in the August one, about why fast matters or why performance is really important. There's a link to a video version in the slides. And that will really go into depth about why it's important across every single different website. I can't cover it all today, and I don't want to just rehash everything he said, so I do really recommend checking out that video. But in terms of our clients and as a business, when it comes to e-commerce, your revenue pretty much comes out as this calculation. So you have an enormous volume of traffic coming in, a portion of that is going to convert into actually placing an order. And then if you look across all your different orders, you're going to come out with an average order rate. So if you multiply all of these things together, you'll ultimately end up in your revenue. And the good thing about performance is they can improve all three of these areas. So if we just start with the traffic coming into your site, there's a great case study from Pinterest where they just rebuilt their site to be a little bit faster, didn't change any of the user experience or anything like that. They simply just made it that little bit quicker, and they saw a 15% increase in traffic coming from just natural Google results. So organic traffic that they're not even paying for. Now, one thing that Google does is it actually factors in the performance of websites into that ranking algorithm. So if your website's faster, then you'll rank higher in Google, and obviously you're going to get more traffic. But what you might not be aware of is this only currently happens for the desktop side of things. So if you're on a laptop or a desktop computer, then you're going to be seeing those faster sites ranked higher and the slow sites will get pushed to the bottom. But it's not actually in mobile searches yet. And next month, in July, they're going to be introducing this to mobile indexing as well. So what this means is the sites that are quicker on mobile devices are going to rank higher, and again, slower ones will drop to the lower of the list. Now, this has been significant, as you can see, for Pinterest, and they've got all this traffic just for desktop improvements, nothing to do with mobile at all. With a mobile device, you're far more constrained. You've got low CPU, low amount of memory, at best you're going to be on 4G. Whereas you compare that to a desktop environment where you're plugged into a fiber connection and you've got nice low latency there. So when this gets introduced, the likelihood is that this is going to be far greater in its impact to those search results. So if you've got a slow website, you're going to probably drop a lot lower than you would have done with the desktop indexing. So this is really, really important. Moving on to the conversion side of things, I apologise, this is a really, really massive quote. But effectively, Mobify are a company in America who deal with various different types of optimization. They were built around a library handling responsive design when that first kind of came out. And they found that for every 100 milliseconds that was chopped off their homepage load, they increased conversion over 1%. And that ultimately led to over 300,000 across their client base on average in terms of increases in revenue. Taking an e-commerce specific example, if you make that change at checkout, so instead of improving your homepage, actually improve the checkout experience, and this could be a traditional retailer, or it could be a ticketing service or something like that where you're booking something and paying for something, that effect is far greater. So your conversion goes up by over 1.5%, and this is just for 100 milliseconds. It's almost invisible to the human eye. And ultimately for their client base, it was over 500,000. So this is, again, quite important. And then when it comes to the average order value, I've got an anecdote from one of my clients. They saw that as they improved performance, they did a similar thing to Pinterest, where they just rebuilt around performance, not really changing the user experience. They saw almost a 10% increase in the number of pages people were visiting as they browsed around their site. And what this ultimately led to is people getting far more immersed in the content, more immersed in the brands, seeing things that inspire them, going, oh yeah, I'll buy that pair of socks with this pair of trainers or whatever it may be. And ultimately it led their orders and their baskets to be far, far larger. So almost 10% increase again in average order value. So ultimately, performance can increase all three of these areas, and you get more money out the back of it. But it isn't that easy, and that's what I'm here to talk to you about today. When you're trying to sell this into clients and get buy-in from stakeholders or managers to get time to work on this stuff and really invest in it, it's easy to throw out all these numbers, but everyone's like, well, my site's a little different to that, or you've got to kind of cater in things like the scale of the website. So what about taking a different approach? This is one of my favourite quotes. It's by an absolute badass called Grace Hopper. She was a US Navy, I think she was an admiral or something like that, quite high up. And she was one of the first computer programmers, basically. She actually invented the first English-based programming language back in the 50s. So, yeah, complete badass. She got into computing at the age of 38 as well, so it's never too late for any of us. And yeah, so the quote follows that it's easier to ask for forgiveness than it is to get permission in the first place. So if we can make some changes that don't require permission in those awkward conversations with our stakeholders or with our clients or managers or whomever it may be, if there's some changes that we can make, then that just gets far easier. We don't waste all this time communicating. So ultimately what I'm here to say is that you don't need permission to build a fast website. You might need permission to build the fastest website. The trouble is you're going to have to change infrastructure to get that far. You'll have to bring in a content delivery network or optimize things like your DNS. So you're getting really advanced, but there's plenty that we can do just by making really tiny tweaks to our websites and that are going to boost all this stuff. So I'm going to show you some of those examples today. But before we start optimizing this stuff, there's a few things that we need to look at. So first of all, we shouldn't be doing any of this stuff without actually monitoring what we're doing. The last thing we want to do is a website to tank in terms of its conversion or something like that, and then us to get blamed for it. So we need to ensure that we are monitoring that performance. And similarly, if you vastly improve things, you don't want the marketing department to go, hey, yeah, we just did really great this month. You want to be able to say, no, we improved performance by 10%, and look at the revenue that we've driven out the back of it. So when it comes to monitoring this stuff, there's a couple of really great tools that you can use. You can start with just Google Analytics. It has a really basic kind of performance monitor in there. It's not the greatest, but you can install add-ons to get more out of it. If you want something very performance specific, this is one of my favorites called Calibre. And it'll do monitoring on a kind of schedule basis. And you get all the variety of stats that pertain to performance. So you get things like the response time of your server, but then you also see things like the first contentful paint, so when do people start to see something on a screen, all the way down to things like when the page is interactive and when it's fully complete. So you can really monitor everything in this. Another one is speed curve, and this is a really great one because it will actually allow you to monitor your competitors as well. So you can put in all the different websites that you care about, and you think, well, I should probably be faster than my competition. This will allow you to track against them as well. So it's a really, really great tool. And the second point is just to understand your users and build for the future. So if you're embarking on doing some performance work, then obviously you need to understand the techniques you're going to be using and what that kind of pertains to when it comes to browser usage. Are people using really old browsers that you're not going to be speeding up? Or is that old browser usage kind of falling off a cliff? For example, with one of our clients, we found that Internet Explorer was just disappearing off the face of the earth, so effectively there was no point in building for that environment. At the start, we had a reasonable amount of usage, but by the time the project was going to be complete, it dropped so low that they didn't care about it anymore. So it's worthwhile bearing these things in mind, and just bear in mind that it's not only the browsers that change, but devices as well. So mobiles are going to get a little bit quicker. Certain screen sizes might drop out of vogue and things like that. So when it comes to applying these optimizations, and as I had to test this stuff to prove to you guys that it does actually work, I couldn't just turn off optimizations that we put into our clients' websites. They'd probably be pretty annoyed about that if we made things a lot slower. So I built a little side project called the slowest site in the world. It's a little bit hyperbolic because it's not actually the slowest. It got to the point where if I was running some tests, it takes so long to run that it was just frustrating for me putting my own talk together. So I had to make it more of kind of an averagely slow website, so something realistic to the kind of things that we're going to come across on a regular basis. So this is available on GitHub. You can fork it and make some optimizations yourself and test your knowledge. You could use it for training and things like that. So feel free to go and check that out. And in there, there's a bunch of pull requests that are all open with the optimizations applied, so you can actually see a before and after of the different changes. If you scroll down to the bottom, there's a deployment button. So if you've ever heard of Heroku, it's just a tool for deploying sites. What you can do is click that, and you'll get a form like this. You type in an app name, and it will deploy it for you, so then you've got a real live actual website that you can use to test against. Because when it comes to running these tests, we're going to be using various tools that expect an external URL and not be running off your own machine. So this is completely free. You can just get signed up and you don't have to put in a credit card, I don't think. And then the tool that we're going to be using for actually testing this stuff is called Web Page Test. So the URL in the corner up there, webpagetest.org/easy, just makes the form really short. There's loads of advanced options for this stuff, but it starts with an average Android device. So Moto G4 is kind of the average power. It'll automatically pick slow 3G. So we're trying to look at kind of what realistic connections people are going to be having. I actually upped that to regular 3G because I thought it was a bit stingy to go that far. And you can see the kind of improvements that we're going to be having even on the regular 3G connection that we all probably experience day to day. So yeah, it's as simple as putting in your URL and then hitting start test, and you'll get all manner of stats out the back of it. In terms of the slowest site in the world, these are the results that we get. So we've got 4 different metrics that we're paying attention to today. We've got start render, so that's the time before you even see anything on the screen. So up until that 6.5 second point, people are just sat looking at a blank white screen, wondering, is this site actually even going to load? Is it crashed? Is it my Wi-Fi? Do I need to switch that on and off and ultimately get distracted and go elsewhere? So 6.5 seconds is actually quite a long time. Then we've got speed index. So this is how much of your site is visible over time. So effectively, the lower the better. This means that a lot of the content is coming further and further as the seconds progress. We've got time to interactive. So this primarily relates to our JavaScript. This is the time it takes to be able to scroll up and down, tap buttons, and actually interact with your site. This should ideally be as low or lower than your start render time, because it means that as soon as there's something on the screen, people can immediately interact with it. So whilst that is faster, it's still not a great, 4.5 seconds is a long time to wait to press a button effectively. And then bandwidth. This pertains mostly to kind of up and coming markets. But even just to day-to-day users as well. Most people are still on capped data plans, even if you've got a lot of data there. We should be respectful of that. There's a significant portion of the world still on pay-as-you-go, so every kilobyte that we send to them, they're getting billed for at the end of the month. So this is really important. And this is all just from 16 requests. So not a complex website with hundreds of different JavaScript files and images and things like that. This is just 16 requests. Now, looking at stats is really boring, so I've actually got the video, and you'll get this if you use Web Page Test. You can just watch this video, and this will give you an image of how the website actually loads for someone on regular 3G on that Android device. This is actually run on a real Android device as well. So I'm going to go ahead and hit play, and you can see the seconds counting on the bottom. So 6.5 seconds actually does feel quite like a long time, right? So we get all the content pretty much pinged in at the same time, and then we've got this enormous image at the top that slowly loads in. Put a nice picture of Leeds, my hometown, in there to do a bit for tourism. And at 18.2 seconds, we get the site completed. I don't know why it grays out the video when it's done, but that's what it does. So it's not a great experience for people. We're waiting all that time for some content to even appear, and wondering, is it loading? So, as part of giving this talk at different conferences, traditionally I've actually optimized the conference's website and applied all the different things that I've done as part of this talk to their websites. But Tinel doesn't actually have a site. So one of the sponsors has kindly donated their website to me to make these optimizations to. So I didn't get kind of background access or anything like that. I just looked at all the HTML and assets and downloaded them all, and then made some changes and ran the tests against it. So similarly, I've got another video which demonstrates how this one loads in. And at the end of this talk, I'll show you a kind of before and after, so you can see side by side the two versions loading. But again, we have quite a long time before anything appears, and then the site loads in. Now, it's worthwhile bearing in mind, as part of measuring this stuff, you've got to understand your kind of target market. Is this site making millions and millions and millions? Because ultimately, if it's not, then it probably isn't going to be worthwhile making all of these changes. So understanding your clients and what's worthwhile optimizing is something that's really important. Again, looking at those stats, got a similar kind of makeup to the slowest site in the world. There's a lot that we can do here, which I should be able to improve. So one of the ways that I started to optimize this stuff is a really cool thing built into Chrome called local overrides. So what you can do is actually edit their HTML before downloading it and managing it. And what this will do is actually save it locally as a copy as you're editing it. And then when you load the page, it will replace the content with the one from your laptop or your machine. So all I had to do to start this stuff is literally open up Chrome and just start tinkering around and changing the website. And then each time I refresh, I get the website as if I've edited it, not the original one, even though I'm hitting the URL. So that's a really, really useful tool built into Chrome. And then when it comes to these optimizations, we're going to go down the stack of actually loading out a website. So we're going to start with a connection. As mentioned, that I'm not going to be changing any infrastructure here, so it's going to be a fairly limited section. I'm going to move on to the HTML and getting that in front of people. Obviously, we can't do anything until that's actually been loaded. I'm going to move down to the CSS, because obviously then we need to style the site. Web fonts are kind of part of that styling, so we'll move on to that. And then finally, we've got JavaScript, which is a really tricky one because everyone uses different frameworks and libraries. And then finally, images, which is kind of always loaded asynchronously and kind of at the end of the process, but can have enormous impact on performance as well. So, if we kick things off with the connection, as I mentioned, I'm not going to be changing any infrastructure, but it's worthwhile checking that certain things are turned on. So go and meet your ops people, or if you've got someone who manages these kinds of things, your content delivery networks and things like that, get to know them and understand what feature set you have access to. So the first thing is just checking that you've got some compression enabled. Most things out of the box these days will have this, so having gzip or Brotli. Brotli is the new one, I think it's Google who came up with it, and that's a far smaller format, so I think it's about a 30% improvement or thereabouts, so you can actually get less kilobytes transferred as part of that. OCSP is simply, as part of loading a website, if it's got an SSL certificate, your browser has to check, has that been revoked? Is it on a list that says that's no longer valid? Now, your server can send that down with the SSL certificate and say, actually, this hasn't been revoked, here's the proof. So rather than your browser having to go off to another third party, even before any connections even really made to your server, it's saying, I need to check that that's actually valid. So this just means that it optimizes that process and you don't have that other third party as part of your browser loading this stuff. Third one is HTTP2. You'll get about a 30% boost just by turning this on. So it's a fairly simple thing to do. Things like Apache and Nginx and modern technologies, most content delivery networks support this stuff. So if it's just a case of a checkbox, hopefully you won't have to change anything and you can just get a 30% boost for free. And then the final one's a bit of a silly one. I've once experienced a site that every file had connection close in the headers. So that meant that every file that got downloaded then closed the connection and it had to reinitiate everything for the next file. So when you've got hundreds and hundreds of different files that are making up a website, it's having to repeat this process hundreds and hundreds of times. Now that should never be the case, but it's worthwhile just checking that you do have that header in there as part of the response. So I didn't do it before and after for these, because it'll all depend on what people's different setups are and whether you can do these things, and it's not really fair because it's kind of infrastructure related. So I'm just going to skip ahead to the HTML section. Now, what I'm going to start with here is just the most minimal change we could possibly make. So we're just actually going to look at the head tag. I'm not even going to go into the body and changing any of the content. how images load or anything like that. We're just purely going to look at that head tag. So really simple stuff to start. I mentioned Harry, who's spoken at Tinel before. He's come up with this most optimal order for loading things in your head. So simply just reordering the tags in there can give you a performance benefit. He hasn't actually blogged about this yet, so it's a bit of a kind of preview. So we should start with our character encoding. That tells the browser like what format is this HTML in, what are the characters. The point at which your browser finds that tag, it has to reparse from the start if it's got it wrong, because it'll make kind of an assumption. So getting that in as soon as possible makes sense, so it doesn't get all the way down and go, oh, I've got to start all over again. Getting in the viewport, just as part of that, so it knows the size of the site that's going to be loaded in. We've then got our title tag, and this is a really important one. If you put a blocking script or something like that before your title tag, what will happen is you'll get that white screen and there'll be no recognition, nothing to identify the fact that the website's even started to load. If you get your title tag in, most browsers will display like the actual site name in the tab that you have open, so you're actually giving some level of indication that something is indeed actually loading. And that's really important, so you just don't lose those people. Next up, we've got resource hints, and that's something that I'm going to delve a little deeper into. So I'll follow that up in a little bit. We've got our scripts. We're going to do inline ones first, then we move on to our styles, and then finally any external scripts. So things like third parties, or even just an actual script file that you might have, rather than embedding it in the HTML. If you've got something that just has a .js extension, you should be loading that as part of those external scripts. And then finally, all the other bumps that you get, like open graph tags for Facebook or Twitter card tags and all that kind of stuff. Those can just be dumped to the bottom, because it doesn't mean anything for loading it in a browser. So what you should be looking out for, you'll get one of these waterfall charts. You can either view them in Chrome, or you can get them as part of running that web page test. So you can see the breakdown. This is this slow site, so you've got 16 files. And we can see here, with this red rectangle, that we're actually starting a whole new connection here. That's what these little 3 bars are. Now we know we're going to be loading some web fonts in from Google, because we built the site to do that. So we can actually tell the browser up front, you're going to be doing that. And the way that we do that is using resource hints. So there's kind of 4 main ones. And effectively, this most simple one is just starting with a DNS prefetch. So if you know you're going to be connecting to a server, the browser will have to look up the IP address for that server based on its domain name. So you can tell it up front, look, we're going to be connecting to this server online. You don't know about it yet, but I'm going to tell you now. Go away and look up its IP address. This is really useful if you know the domain name that you're connecting to, but you don't know whether it's going to be over a secure connection or an unsecure connection. So it doesn't really happen that often. The more common one is pre-connect. Usually most sites nowadays are built over HTTPS, so you can pretty much say, yeah, go away and just create this connection already. We're definitely going to need it. So if you've got something like an image CDN where you're serving images from a separate domain, or you've got any kind of third parties that you're using, then you can just throw them in a pre-connect. The URL might change, but you've not told it a specific URL. You've just said, hey, this domain, we're going to need a connection for it. Next up, we've got preload. So I mentioned that specific URL. If you do know the actual URL that you're connecting to, i.e. you're loading a CSS file from Google Fonts or something like that, then you can put that specific URL in and tell it, go away, download that file, and just have it sat in my cache waiting to be used. And then the final one is prefetch. So if there's anything on a future step, so people are going to browse around multiple pages on your site and they're going to need some, you can kind of preempt where they're going, then you can use a prefetch. And what that'll do is similar to preload in terms of it downloads a file and puts it in the cache for you, but it does it with a lower priority. So it'll load all the other stuff first, and then it'll drop that at the bottom. The browser support for this stuff is really, really solid. So the great thing is that this is a progressive enhancement. If you're on an older browser, yeah, you're going to have a slower site experience, but it's not going to break anything. It doesn't change anything at all related to the user experience. You don't have to have fallbacks or polyfills or anything like that. This will just natively work. Pretty much the same goes for preload as well. It's in all the latest browsers. As part of looking at the Tech City site, I found that there was some already in there as well, so this is the kind of format for them. You can do them either as a link tag in your HTML, or you can actually put them as a header as well. So there's kind of 2 options depending where you want to serve them from. Now, literally all we've done is swap around some tags and maybe add a couple of these, and we can look at the results now. Why does it always get stuck on that slide? There we go. So, we've chopped over 1 second off that start render time. If we look back at the Mobify case study where we had that 100 milliseconds pertaining to $375,000 extra a year, we could potentially be making an extra $6.7 million a year for those clients. Obviously, again, it will depend on the kind of size of clients that you're dealing with and things like that, but this is a lot of money. We're giving a far better experience. It'll be down at like 4 seconds of looking at that white screen now, so people are going to be more likely to stick around and see the rest of your content. Not quite sure what happened to speed index. It's such a small value when compared to the overall total that it didn't really concern me. Times Interactive has changed a little bit, but we've not really touched our JavaScript, so we weren't expecting any change. And then bandwidth is primarily dominated by our images and our assets, things that we're loading in, and we haven't changed what we're loading, just how we're loading it. So that shouldn't have changed anyway. So next up, we've got our HTML, our document, and we need to start styling it. So CSS is the next most important part of that. The first step is literally just removing the use of @import. You may have come across things like concatenation before, where you're merging these files together, but also you should be looking out for third parties as well. So you may be using things like Google Fonts as part of an @import. Now what this means for a browser is that it'll load your CSS style sheet, and then suddenly it discovers a whole bunch of others once it's downloaded, parsed that file, and discovered those URLs. So there's a kind of cascading approach. You can get around that by using those resource hints, but ultimately, if you do have a third party in there, like Google Fonts, then effectively you're letting Google control not only your uptime, but your performance as well. So if they have a slow period, then your site's going to be hammered. If they're completely offline, browsers will actually wait around 90 seconds before they give up on that file. And this is all before someone can even see anything. If this is loaded synchronously, then effectively people are sat there waiting for Google Fonts to load before they can see anything. So once you've got your CSS kind of all bundled together, you should look to inline it. And this is one of the requirements of Google AMP for those that come across that. And what this will mean is as soon as you've served that HTML to someone, they've immediately got those styles. Now the tricky thing is if you've got an enormous style sheet, if you've got half a meg of CSS or something like that, you don't want to be inlining all of that into every single HTML page. So that's where critical CSS comes in. And there's various different tools you can use for that. And what that does is look at effectively what CSS is needed for the browser window when it first loads the website, and bundles just that in. Now, you can use a fancy tool. There's various different NPM modules and things like that. But the most simple thing to do is just look at your Google DevTools. This is, again, the TechCity site, and what I've done is just popped open the Sources tab, and it gives you coverage. So this is showing us how much CSS is actually used versus how much is loaded, how much JavaScript is used versus loaded. So we can see that 82% of the CSS that this site loads isn't actually used to render the first part of the page. So we should be able to chop out most of that, and you could just copy and paste it if you've got a static site. You can look down at all the red bars and remove that out of your CSS, or you can automate it with some sort of build process. And then for the rest of our CSS, we just need to make it asynchronous, where we load the rest of that 82% in below the fold, asynchronously after the rest of the files have loaded. So by the time someone starts to scroll, they're going to see the rest of the site styled. It's not going to be a case of scroll and then everything looks like it's the 90s thereafter. When it came to the TechCity site, I could see that there was 3 different files here. And one thing that I wanted to just call out, because I've had quite a few questions about this, is the impact of HTTP2 on this. Traditionally, we've always been told to merge these files all together. HTTP2 came along. There's a lot less overhead when it comes to requesting more and more files. And one thing to bear in mind, and this is a very, very small thing when it comes to these ones, is if you bundle more things together, your compression gets better because it works with repetition and reduces that repetition down. So effectively, if you do combine files, you can still get savings there, and depending on how many you have and how large each one is, it may be worth you bundling certain ones together, it may be worth keeping them apart, so it's just worthwhile testing this stuff repeatedly. So when we come to look at our results for this stuff, not a lot has changed. We've knocked off 100 milliseconds, which gives us that $376,000 a year, but it's not really that big of a deal. We've kind of, not really achieved anything by making these changes. This is whilst the sites are all optimized, all performing optimally. So if you have something like Google Fonts, as I mentioned, it'll wait 90 seconds, your browser will wait 90 seconds to download that file before it goes, oh, it's not coming, I'll give up. So if Google Fonts was offline, we'd see something more like this. We'd see that our start render is up at that 90-second mark. We couldn't even calculate the speed index. And you can actually test this through web page test. There's actually there's a tab on the more advanced form where you can put in URLs and it'll just black hole them. There's a bunch of IP addresses that you can also use for this, so you can actually test it as well. So this could potentially happen. Now, the value of this, I don't think any site is going to be that dependent on Google Fonts and lose 339 million a year. It would be pretty bad for Google Fonts to be offline for an entire year and for no one to actually deal with it if they actually use it. But the more realistic case is that it's offline for an hour. Now, even Amazon and people like Google, do have downtime from time to time. Amazon S3 managed to go offline even though it's just static file hosting, and half the internet went down with it. So just 1 hour of outage with Mobify's user base, their customer base, could cost them $40,000 an hour. So this stuff is really significant if there are outages and you are dependent on third parties. As part of our loading in our CSS, typically we're going to be loading in web fonts these days. We've got this new power to load in our custom fonts on the web and give clients the designs that they've always hoped for. But people really undervalue the impact of doing this on a site in terms of its performance. Similarly to our CSS, we want to start with making sure that we're self-hosting them. Depending on what services you use, this may not always be possible. Things like Typekit charge you a lot of money if you want your service to actually deliver them, because they want to collect all the royalties from serving those web fonts. So this may not be possible, but if you're using something like Google Fonts, you can basically just take a look at their CSS, copy and paste the files, and you're golden. That way you'll avoid an extra DNS lookup, you'll avoid an extra connection, you'll avoid having to do another SSL check, and ultimately you'll be serving this stuff yourself, so you have full control over it. And one thing to bear in mind when it comes to these self-hosting aspects is things like GDPR. I think you guys had a talk about that last month. If you're using these third parties, there is a potential that they could be tracking your customer base by including these files. So if you're using Google Fonts, I think there's actually an open issue on their tracker about what it means for GDPR. Because effectively they can reach in and see things about your customer base. Now they may only be recording IP addresses and things like that, traditional information that's not really that important, but GDPR's come along and kind of stirred all that up. So it's one thing to bear in mind for the sites that you may already have in production today. Now, one of the great things about fonts is that we've just gained the ability to control how they're loaded. So we talked about how CSS can be loaded in these funny different ways, like splitting things out so you've got your kind of master viewport inlined and then anything beneath the fold is loaded asynchronously. You can kind of do the same thing with fonts now as well. So there's a new CSS attribute and you put this inside the font face group, and basically what this allows you to do is control how it's rendered. So traditionally browsers will just sit around waiting for those fonts to arrive. They won't paint any text, there'll be this invisible text, and then at the point that they're loaded, they'll then render that. But that's a pretty bad experience if you've got your fonts take a while to download, particularly on those slow devices, and then you want to control that experience a bit more. And one of my favorite ones to use for this is swap, the actual value. And what this means is render using the fallback fonts that we already have built into our browsers, and then when the new font arrives, swap it in. So re-render the page with the actual real font once it's arrived in. So that means it could take a few seconds, not really a problem. Someone can actually see something on your site and interact with the site. They're not sat there waiting for it to be loaded. The trouble with that is that you're going to get that kind of weird jarring effect potentially where the font loads and then it swaps, they're already starting to read something and they're like, oh, that changed. So a better option for many people is to use optional. And what that does is basically say, go away and load those fonts. If they arrive back really, really quickly, then re-render the page so it feels like part of the normal loading of a website where things are rejigging around a little bit. But if they don't arrive in a few seconds, just don't bother with them. Just leave it as it is, and people can keep browsing around, and then the next page that they visit, obviously they'll be sat ready in the cache at that point, and at that point they'll render with the proper font. So the second page means that people will get that branding and those fonts in. Obviously this is going to be a lot more jarring to clients, so it's not something that many people kind of go with, and it doesn't work with if you've got a single page application where you're serving an entire site without making multiple page requests, because you're never going to get that re-render unless someone literally leaves the site and comes back to it in the future. So swap's usually the best one to get started with, but if you are finding that people are finding the flicking of the fonts a bit awkward, then you can always use optional as well. And this has got pretty decent support across the new browsers. Again, browsers that don't understand it, just ignore it, so it won't break anything. You can just drop that in there and you're good to go. So we talked about how we're loading in our fonts. Next thing is to ensure that we're loading the correct fonts for our browser. WOP2 is pretty much the golden standard format at the moment. It's got really great support across all the latest browsers and going back quite far in history. If you do have a lot of Internet Explorer 9 through 11 users, then you can use WOP1, and then I don't think there's many people who need anything older than that, because you have like TTF fonts and SVG and things like that, so generally people don't need to worry about that stuff. But WOP2 just compresses far better than WOP1, so again you're getting about 30% and decreasing your font size, so that's 30% less data that we're sending across the wire to our customers. The final optimization that I can give you for web fonts is to use Unicode range, and what this does is split up your font files into numerous files and only load the right ones that you need to render the text that's on a page. So if you've got most of your pages only have the kind of basic English characters and don't have all the different accents and things like that, or they only have a common set of accents that you typically use, then you can create a smaller font file that only contains those characters and not really worry about the rest. And then basically instruct the browser to say, if there are characters on the page that do have some other ones, load in this separate file. So on the odd case where you do have these other pages, you're not breaking them. You're not getting this one character that looks all weird and in a different font. So that way we're kind of only loading the actual characters that we need to load in for the given page that the user's on. And the great thing is that this is part of Google Fonts. If you need to do it yourself, there's a really great tool called Glyph Hanger. It's an NPM module, I think, and what that allows you to do is just put in a URL and it'll tell you what characters are being used on that page, and then you can actually use it to create a subset of the files as well. So if we look at the Google example, this is the style sheet that Google loads in for a font. All I've literally done is chop out their host names from the URLs. I've copied those files to be served locally. I've left the Unicode range in because that's what they do for us already. And then all I've done is dropped in the front display swap at the bottom there. So fairly simple change. And we have a pretty big impact again. So this is similar to the original changes in terms of our HTML. So we've chopped off over a second in terms of our start render time. We haven't really optimized the other side of things, so I didn't really expect any changes there. Now we're on to the really tricky one, JavaScript, because I can't give too much advice because some people are using React, some people are using Angular, some people are using jQuery, some people are using Vue. There's so many of these different things that you could optimize them all in very different ways. Then you've got all the different build tools on top, so you've got Webpack and Gulp and Grunt, and there's probably some more that have been created since we even started talking. So there's some basic principles that I can give you, but I can't delve too deeply in this stuff. So the first thing is just, like with all the other optimization techniques, is just to control how we load these scripts in. So by default, unfortunately, browsers default to synchronous script loading. So that means if you put something in your head, it will literally block anything else from loading on the page until that file's loaded. Recently, a couple of years ago, they introduced async as just an attribute on your script tag, and that allowed us to have a bit more control. So effectively that says download the file, but don't wait for it. As soon as it comes in, then execute it. And then there's a really old one called defer. I think this was part of like IE5. I think this was actually in there when I first started web development about 15 years ago. And what this says is download the file, but wait until everything's completely loaded and then execute it. So you're not interrupting that flow as the browser's trying to load in all the files and negotiate all the images and get everything in front of someone. So if you've got something like analytics that doesn't need to happen for the user to interact with the site, that's a really great candidate for things like defer. And here's just a diagram explaining it. This is from Google. So we have our top one where the little blue bar is loading it in, and then we immediately execute it before anything else can happen on that green HTML parsing. When it comes to our defer, we effectively load it asynchronously, so we don't block that green bar, that site loading. And then when it comes in, we wait until the very end, until everything's finished, and then we execute it. And then the final one, async, where we load it in parallel to parsing that HTML, but as soon as it comes in, it's going to block that and actually execute. So when it comes to where we're loading this JavaScript from, you may have heard, oh, you should always load your JavaScript through a CDN. If you see anything like this, then just don't do this. Copy the file locally. This was often pitched as, oh, well, you know, if other people have these files preloaded into their browser, you know, they've been on another site that had jQuery version 3.3.1 loaded in, then they'll already be there. And, you know, that way we get this kind of mass effect of browsing around different sites, and then you'll have that file already sat there and you don't have to download it again. Well, for starters, with Safari, it's a complete lie, because what they do is they sandbox it. So even though your site might load that file from Cloudflare, if you go to another site that loads exactly the same file, it can't see that it's already been loaded. The cache is kind of scoped to your site. And that's put in there for privacy reasons, so that way sites can't detect where you've been by simply including the same scripts as yours and then going, oh, well, we know that they've been to, I don't know, Google, because Google includes this script and our site includes this script. So this is what effectively will be happening to other browsers going forwards. You know, as everyone pushes the kind of privacy side of things, but the same technology that's in Safari today is probably going to get rolled out elsewhere. But even outside of that being implemented in Safari, the hit ratio of these things is just so minimal, you're actually making things worse by including these. Because typically this will be implemented as a synchronous tag. You know, you need to know that jQuery is loaded so that then your code that depends on jQuery can actually utilize it. So again, you're putting your uptime and your performance in the hands of Cloudflare. I mean, hopefully Cloudflare are great, but you know, every millisecond that they add is time your users are sat waiting. JavaScript doesn't come down to just purely the network side of things either. Once it's downloaded, you've got to then parse it and compile it into machine code that then your device can actually understand, and then it actually has to execute that machine code. So there's more to it than that as well. And again, I can't give you too much detail in terms of specific things because, you know, React will work very differently on a CPU to, say, Angular. But what you can do is just minimize the amount of JavaScript being sent. So looking at bundling, ensuring that the right JavaScript files are being sent at the right time, and the makeup of those different bundles, ensuring that you're only sending what's required. And tree shaking is the concept of just removing any dead code. So you might be importing the entirety of jQuery or something very similar, just to use one line or one function. Now all the rest of that is just dead weight. We're never going to need it. So if you implement tree shaking, it just rips all of that stuff out. And then you're only sending literally the code that is actually going to get executed. Again, this will all depend on your build tools and things like that, but there are loads of libraries on the likes of NPM for this stuff. So if you look at the results, we haven't really changed our render times or anything like that, but now our time to interactive is chopped in basically in half. Within 2 seconds, people can actually start scrolling. So when we put all of these things together in a little bit, we'll find that people actually interact with the site as soon as it's rendered, and it'll render a lot quicker. And the final section that I have for you guys is images. This has been something that people have been optimizing since the early days of the web, just because bandwidth was so constrained even on desktop devices back then. But there's a lot of techniques that people still don't quite understand. So the first and most basic thing is the difference between foreground and background images. Now, there's two ways we can load our images in. We can use an image tag in HTML, and that's a foreground image. And then we have background image in CSS. And the trouble with this, that a lot of people don't appreciate, is that this gives a hint to the browser as to the priority of that image. So if we look at a waterfall, this again is the slow site. We can find that we've got this big hero image, that big photo of Leeds, and it's the last thing that we load in, despite earlier things being beneath the fold. So we've got images that aren't even on the screen yet and won't be until someone starts scrolling down. They're loading in as a higher priority than our hero image. Now, it would be far better if we could get that in front of someone sooner. And the reason for this happening is the fact that it was set to a background image attribute in CSS rather than an actual real image tag. So if we correct that, it flips it round. That's all I literally had to do was change it from being loaded by CSS to being loaded by an image tag. Simple as that. Looked at the Tech City site. It's got this enormous photograph of Split. Similar kind of thing. It was the 19th thing that loaded in, even though it was right there in front of everybody loading the site. And again, it was because it was loaded in as a background. So if I corrected that, then it went up to be the third thing. Just literally by flipping it between being a background image and being a foreground image. I've cheated a little bit here because I'd also got my CSS optimizations in, so there would be a few more before it, but it did jump up significantly. When it comes to those images that are beneath the fold that we saw in that waterfall chart, we should be lazy loading them. Most sites have these kind of scripts built into them these days. So if we've got something that looks a lot like this, where you've got these photographs, our red boxes, our viewports, or what people are landing on the site and seeing immediately. And then we should be looking at, do we need to load those in immediately or not? From a user experience perspective, we probably want to load the top row. There was another row beneath this, but I couldn't fit it on the slides without making the images really small. So we want to load a little bit ahead of the viewport, so as people scroll, they're not seeing things flip around. Similarly, we want to get some sort of preview image, so if things do take a little bit longer, then there is something there. And we're not also reflowing the page, so as an image loads in, it's going to move the text up and down. That's the last thing we want. You're trying to scroll, you're trying to read something, and suddenly all these things are adjusting the page. So you can get really advanced with this stuff. Medium, you may have come across, they popularized this technique of using a blurred version of the image as a preview. So it's a lot less jarring. So as you scroll, if you are scrolling particularly fast or if you're on a particularly slow connection, and then you get this nicer experience of seeing that there is some content there, so just a white gap on the page, and then it loads in the actual full file, and then it just fades that over the top. Unfortunately, as far as I'm aware, there's no actual proof that this feels better to users, but it feels better to me. So if it's a fairly straightforward thing for you to implement on your site with the stack that you have, then it may be worthwhile looking at. Again, we've looked at how we loaded our images in, but we haven't yet looked at kind of what we're loading or the formats and things like that. So the first thing is just to serve your appropriate image sizes. Now, again, this harkens back to looking at the analytics that you have around your site. What is the most common user base that you have? Is it primarily mobile, or is it tablet devices or desktop? Because if you're just throwing desktop images at everybody, you might have 70% of your traffic that are loading these enormous images, using up loads of bandwidth, slowing down the whole site, when they could just be fine with a little 400 pixel wide image. So if you can look at initially just optimizing around what the default use case, the average use case of your site is, you're going to see massive benefits there. But if you do need to serve all these different formats, and you do have the ability to produce them, then you can use source set. This is fairly well supported again. It'll all just drop back to using that image source attribute. So again, you've got a really easy fallback mechanism there, so any browser that doesn't support it will just ignore it. This is in all the latest versions. And then what you can do is actually combine that with serving the appropriate format as well for the device. Now, different devices support, and different browsers support different image formats, and they all compress in different ways. Google Chrome and Opera, because they're based on the same rendering system, they support WebP, which is Google's image format, compresses far better than JPEG. JPEG 2000 is available for Safari, and then we've got JPEG XR for Internet Explorer and Edge. So it's a bit of a pain in the arse because you've got all these different formats and they're only supported by one subset of browsers. There's no even crossover between them. But if you can render these, they all get spat out of things like ImageMagick. So if you've got some sort of thumbnailing support in your stack already, you may already be able to produce this stuff. If you can produce these images, then you can actually serve them as well. Now, the traditional way to serve this stuff is by inspecting what the browser's telling your server they support. So you have to look at this accept header. Now the trouble with that again is that you're touching infrastructure, you're having to analyze all this stuff, and there is a way that we can get around with it just using HTML, and that's the picture tag. So the picture tag allows you to respond to various different things. If you want to do things like art direction and say, okay, load in a completely different format when images are on Retina or on different aspect ratios and things like that, you can do all of that stuff with picture. But what we can use it for here is simply saying, okay, well, we've got these three different formats that these browsers support. Try and serve them the most relevant to them. If you can't, just fall back to a regular JPEG, that's fine. And then within here, we've got those different sizes with our source set tag as well. So what I'm doing here, simply saying, if we've got a really wide window, serve a wide image. If we've got a more narrow one, serve a more narrow image. Simple as that. And then ultimately, all of this stuff just falls back to the source tag again, a source attribute. So it's fairly simple to output this stuff. It may be tricky to get all the different formats, but it's worthwhile just understanding what you have access to. And the results were actually quite surprising for this image stuff. I expected bandwidth to go down, because obviously we're compressing things a lot better, and we're not loading images that are beneath the fold. And I expected our speed index to go down as well, because we're getting more content in front of people sooner. But actually, it affected our start render time as well. There was a lot less congestion on that network as your browser's trying to load things like CSS, and it's looking ahead going, oh, I'm going to need these images in a bit. So you can actually get far better performance just in terms of getting things in front of people and not having that white screen just by optimizing your images. And again, this amounts to a lot of money. I could talk about images all day, and there's an amazing guide that's sponsored by pretty much everyone on the web who has to deal with images. So if you need any further information, I really recommend checking out this site. And now we're going to look at what happens when we apply all of these different things together. It's pretty impressive. We've chopped our start render time down to basically about a third of what it was. We're now getting content in front of people within 3 seconds on average 3G. Now, Google have a stat where they found that 50% of people will just disappear and bounce off your site if your site doesn't show something within those 3 seconds. So effectively, we've now got it underneath that value. Yeah, there's still going to be people on even slower connections that still bounce away, maybe give up, but they may be more used to having a slow connection and maybe more accepting of that. So we're in a place now where we're not just losing 50% of our traffic. And one thing to note is if you're tracking this stuff, things like your bounce rate with Google Analytics, if Google Analytics hasn't loaded within those few seconds, then you won't even track that they were even there in the first place. So you might be looking at a bounce rate of, say, I don't know, 5% or something like that. That might actually be 55%, and you're not actually aware of it because your analytics hasn't even loaded and recorded the person that was even arriving to your site. So that's where you've got to look at things like server-side logging. So we've improved things like our speed index. We're getting our content in front of people a lot sooner. Our time to interactive, we chopped in half. And then bandwidth now is at like 300 kilobytes. So we're serving people actually a reasonable amount of data rather than just flooding their data plans. Again, looking at the stats is all pretty boring, so I've copied down the videos so we can do a before and after. So this is the slow site that I built. We've got the original on the left, and you probably want to pay more attention to the optimized version because you're not going to see anything on the original until we see something on the right. So now we find that in just under 3 seconds we start to see something on the site, and then it's completely loaded in 4.5 seconds, whereas the other one hadn't even displayed anything until that point. And yeah, this is just my kind of sample site. I then went away and obviously did this for the split tech city site, and we saw pretty decent improvements here. Now, I didn't go away and optimize all the images, which is why the bandwidth is still quite high. I just simply didn't have time for that. But we can see that we've improved everything else across the board. We've chopped 3.5 seconds off that start render time. I'll share on obviously all my findings as part of this. And the speed index is less than half of what it was. So ultimately, this is the difference in terms of what the site feels like when you're loading it. This is the original on the left, and we've got the optimized one on the right. So again, within a couple of seconds, you're starting to see, and it's pretty much loaded in 4 seconds or so, while this one's still starting to display. There we go. So quite an outstanding difference. Obviously, this is still on a fairly slow connection, so the impact to this won't be as great on faster devices. Hopefully, most people are getting 4G and things like these days. But ultimately, you can make some really massive impacts on performance and on revenue and conversion, or just getting your content in front of people by making some really, really tiny changes. Most sites nowadays will have a lot of these changes already applied to them, but there may still be some outstanding changes that, simple little tweaks like sorting out that head tag and correcting the order there, that can have this immense impact. Now, before I jump off the stage, I do have one little bonus point for you, which is service workers. This comes up a lot when people are talking about things like progressive web apps, trying to replace the native mobile apps. It has pretty great support on all of the major browsers, and it's a progressive enhancement again, so you don't have to worry if it's not there, then people don't get the benefit, but it's going to be there more and more as people progress. And there's various different things that you can do with it. You can actually control the network. It acts as a proxy between you and the server. So you can say things like, you could produce an entirely synthetic response. So you can inspect a request coming in and say, yeah, I'm not even going to go to the server for that. I'm just going to chuck you some content back. You could modify the content before serving it to a customer. And you can effectively kind of man-in-the-middle attack your own website by doing this stuff. And ultimately, that's the basis of things like offline support. So you can detect whether if the network's unavailable or if it's just completely too slow. You can serve people different content. You can do some really advanced things. So you can do stale while revalidate. So if someone's already viewed some content, you can say, yep, that will just give you back that old version. And in the background, I'm going to go away and refresh that. So you're not dependent on waiting for the server to come back. You're just going to get it immediately, but it might be slightly out of date. You can also do stale while error. So if your server comes back and says, hey, we've got an error, the site's got some problem with it, then only you can serve that old version then. And then the final one is, if there's just a little bit of slowness with your third party, you can actually capture that and then serve a synthetic timeout as part of that. And that only takes this little piece of JavaScript. This isn't the entire file that you need to create. What this actually does is say, after 2 seconds, if a response hasn't come back, simply just serve a fake one that says, sorry, it timed out. So that 90-second window where we were waiting around for Google Fonts, we can actually instruct the browser, don't wait 90 seconds, just wait 2. And if it doesn't come in that time, just give up. So we can actually control the browsers a lot more this way. Now, 2 seconds is probably a little too tight. You can vary this depending on what your needs are. And the script currently just has no restrictions, so any request, whether it's a first party or third party, is put through this. So you want a little kind of if condition in there somewhere. But that's really how simple it is to just protect against this stuff. So that's all I have for you. Thank you very much. If you have any questions about anything at all, I'm going to be sticking around for the next few hours at the very least, depending on how much alcohol you can pump into me. So thank you very much. does anyone have any questions now, or do we want to sort drinks, or what's the plan?
Yeah, I have a question.
Cool.
Have you ever tracked the audiences that were affected by these improvements? Meaning, does the revenue come evenly from the whole audience after the improvements, or is it more the users that have bad performance and then went up into a goodish performance?
Yeah. So you do get a kind of long tail with performance. So you get most of your customers generally will get your site pretty fast. And then you get the kind of trough going off at the end, and you get loads of people. You know, if you take that area of people, it's quite a lot of people, but it is spread. You know, as it gets far and far worse. With that, you do get far more benefit from those people, but we have seen that the audience that get your site quickly most of the time are also the people that do get it slow as well. So you find that your own customer base becomes more loyal effectively. It's not just about you know, finding these people who are always on slow connections. It can be you know, it could be someone on the latest iPhone who usually is on, you know, the fiber connected Wi-Fi in their office, but then they're on a flight and, you know, suddenly their site's really slow. It's having to go ping around satellites and things like that. Or it can be someone just traveling on a train and they're going in and out of tunnels and things like that, or into rural areas. And there's so many different circumstances where you get poor connectivity. It can even be when the actual cell providers get bottlenecked. So if you go to things like festivals, you know, you might get a strong 4G signal, but there's so much bandwidth from all the devices nearby trying to get pushed through that network, you simply can't load anything. So there's so many circumstances, and it's not just kind of emerging markets and things like that where things are always slow. It's your core customer base as well. So you do see a massive uplift just in things like loyalty, the amount of times people will return to your website and things like that as well. Anyone else?
Sure.
All right.
Is there like a script or a tool that will like give us this information, what to improve on the website, or at least in the HTML, and then maybe I can run it and improve it?
Yeah, so some of these aren't optimized, but there's a really great thing built into the Google DevTools. There's an audits tab, and within that you can run a performance audit. It's a thing called Lighthouse. It's a separate script, but they built it natively into Chrome now, so anyone can just open that DevTools and just hit run, and it will give you a breakdown of where that slowness is coming from. So you can see, you know, is it my images, is it CSS, is it JavaScript, you know, all these different things. It will actually illustrate very clearly to you. A lot of those do have kind of recommended ways to fix them, but a lot of it is manual, unfortunately. Yo.
I don't have a question, but if that's all, I would like to invite you all to join us.